This is section 8.3, part A, dot product and vector projections. Your I can statements for this section. I can find the dot product of two vectors and use the dot product to find the angle between them. And I can find the projection of one vector onto another. Consider two perpendicular vectors in standard positions A and B. Let vector BA be the vector between their terminal points as shown in the figure. So both of these vectors are starting at the same point. Their initial points are together, but they're going perpendicular to each other, so their two terminal points will be away from each other. If we draw a vector BA that goes from the terminal point of B to the terminal point of A, this is the vector we're describing. By the Pythagorean theorem, we know that the magnitude, or the length, of vector BA squared is equal to the length of vector A squared plus the length of vector B squared. Expanding with the Pythagorean theorem, we can find that the magnitude of A squared plus the magnitude of B squared is equal to 2 times A1 times B1 plus A2 times B2. This expression A1 times B1 plus A2 times B2 is called the dot product of vector A and vector B, and it's going to be denoted with a dot between them, so it'll be A dot B. So the dot product of vectors in a plane, if we have vector A and vector B, the dot product is going to be A1 times B1 plus A2 times B2. And that's going to tell you the length of the vector that connects the two terminal points if those two initial vectors start at the same point and are perpendicular to each other. The vectors A and B are orthogonal if and only if the magnitude is 0. So we need to find the dot products of U and V and then determine if U and V are orthogonal. So we said to find the dot product, it's going to be A1 times B1 plus A2 times B2. This is your A1 and your A2. This is your B1 and this is your B2. So we're going to do 3 times negative 4 plus 6 times 2. 3 times negative 4 is going to give us a negative 12. 6 times 2 is 12, which is going to give us a dot product of 0, which means this is orthogonal. On the next one, this is our A1, A2, B1, B2. So we're going to do 2 times 8 plus 5 times 4, or 16 plus 20, which is 36. So this is not orthogonal. Properties of the dot product. If U, V, and W are vectors and K is a scalar, which remember just has a length, it doesn't have an angle or direction associated with it, then the following properties hold. So we can use a commutative property. It doesn't matter which vector comes first and which one comes second. You are allowed to switch them. The distributive property holds, so you can add the two vectors and then do the dot product, or you can do the dot products separately and then add the two back together. Scalar, you can take it and distribute it to each piece, distribute it to one of the vectors or distribute it to the other vector, or you can do the dot product first. The zero vector dot product, if you multiply a vector, if you use a dot product with a vector and 0, you're just going to get 0. And to find the magnitude using the dot product, you're going to take the value of the vector, you're going to use the dot product with itself, and that's going to equal the magnitude squared. So if we use the dot product to find the magnitude, we just said that U dot U is equal to the magnitude of U squared. So if we do U dot U, we have the same vector twice. This will be our A1, A2, B1, B2. So we're going to do negative 5 times negative 5 plus 12 times 12. This is going to give us 25 plus 144, which is equal to 169. Now that is equal to the magnitude of vector u squared. To get the magnitude by itself, we are going to take the square root of both sides, and the magnitude of vector u will just be 13. If you need to find the angle between two vectors that are perpendicular to each other and are going in opposite directions, if theta is the angle between non-zero vectors, a and b, then to find the angle, cosine of theta is equal to a dot b over the magnitude of a times the magnitude of b. So on the first one, let's go ahead and find our u dot v, our magnitude of u, and our magnitude of v before we get started. So our u dot v, we're going to have 6 times negative 4 plus 2 times 3, or negative 24 plus 6, which will give us a negative 18. If we do the magnitude of u, we're going to have the square root of 6 squared plus 2 squared, or the square root of 36 plus 4. So the magnitude of vector u is going to be radical 40. If we find the magnitude of vector v, that's going to be the square root of negative 4 squared plus 3 squared. Negative 4 squared gives us 16, 3 squared gives us 9. So the magnitude of vector v is going to be radical 25. So we know that the cosine of theta is equal to a dot b, which we have found a value of negative 18, over the magnitude of a times the magnitude of v. Since both of them are in the square roots, we can multiply those values together. 40 times 25 gives us 1,000. So our denominator is going to be radical 1,000. Now remember, when you're looking for an angle, to get the angle by itself, you do the inverse of your trig function. And we're going to get the theta is approximately 124.7 degrees. If we try this again in the second example, again we're going to start by doing the dot product. U dot v is going to give us 3 times 3 plus 1 times negative 3. 3 times 3 is 9. Negative 3 times 1 is negative 3. So u dot v is going to give us 6. If we find the magnitude of unit v, it's going to be 3 squared plus 1 squared, or 9 plus 1, which is going to give us radical 10. The magnitude of unit vector v is going to be 3 squared plus negative 3 squared, which is going to give us square root of 9 plus 9, or radical 18. We go to find our angle. The cosine of theta is going to equal u times v over the magnitude of vector u times the magnitude of vector v. Again, they're both in the square roots. So we're going to have the square root of 10 times 18, or the square root of 180. When you need to get the theta by itself, you do the inverse of your tangent function. And in this case, our theta is going to be approximately 63.4.